Hey, math friends. So today is our kind of third lesson on solving quadratic equations. We did our first go around was with graphing, and then our second go around was with factoring. Okay. Now, you could subtitle this lesson, What to Do When You Can't Factor, because this would be your go-to. Okay. Now, for those of you who like to know these things, there is another process that we teach in 20-1 called completing the square that you're not responsible for in 20-2. But essentially, the quadratic formula comes directly from that process of completing the square. So I say that only to say, don't look at a formula and think that some math teacher just sat down and said, oh, this looks like a cool formula. Everything comes from something, right? And so, you know, if we had time and I didn't stress you out with it, I would show you the derivation of the quadratic formula. And if you're dying to find it, I do have that in a 20-1 video that you can look up. It is quite fun. But for 20-2, I'm not going to show you the derivation of it. I am just going to introduce the formula and we're going to show you how it works. But please, please, please understand, it doesn't just come from thin air, okay? There's a reason that the formula says what it says, and it all comes from, okay, let's just take this random quadratic, call it a squared, ax squared plus bx plus c, and let's complete the process of completing the square on it with just those letters, and what comes out is, oh, x is always going to equal blah, this, okay? And the cool thing is, then it tells you where all your A's are in the answer, where all your B's are in the answer, and where all your C's are in the answer. So the quadratic formula ends up being, you write down what A, B, and C are, and then you just plug it into the formula. That sounds really easy. Lots of kids, when I first show you the quadratic formula, they're going to say, oh, why did you make me factor for the last couple of days? For a couple of reasons. Factoring should always be your go-to. And you may not believe me yet, but factoring usually is the quicker and most efficient way to get the answer, if you can, okay? The quadratic formula is where you turn if you can't factor it, or if your numbers are like really weird, it's not worth trying to factor it. If your numbers are really weird, you can just go straight to the quadratic formula for that, okay? So let's get into it and see how we do. Quick review of factoring. If I was to ask you to solve this by factoring, you would look at this and say, oh, okay, I can do that. This is a difference of squares, okay? So I've got x squared minus 16 equals 0. That will factor into x plus 4 and x minus 4. So x plus 4 times x minus 4, that's the zero product principle. So either one of those could be my 0, x plus 4 equals 0, or x minus 4 equals 0. If x plus 4 equals 0, I have x equals negative 4 because I subtracted 4 from both sides. And if I have x minus 4 equals 0, I have x equals 4 because I added 4 to both sides to get the x by itself. Okay, so two answers here, x equals negative 4 and x equals positive 4. Okay, remember what we're doing. Those are the only two values for x that I could plug back into the original equation and actually get a true statement. And because that statement says equals 0, those are the x-intercepts of the graph as well, okay? Just trying to connect all the visual and algebraic work that you've been doing. Okay, x squared plus 8x plus 7, I would be looking for two numbers that multiply together to give you 7 and add together to give you 8. Well, those numbers are 1 and 7. 1 plus 7 is 8. 1 times 7 is 7, okay? So x plus 1 times x plus 7 equals 0. That's the zero product principle. Pull each one out and have a separate discussion about them. If x plus 1 equals 0, x will be negative 1. And if x plus 7 equals 0, x will be negative 7. Two solutions, x equals negative 1 and x equals negative 7. Okay. All right, x squared plus 5x minus 7 equals 0. I'd be looking for two numbers that multiply together to give you negative 7 and add together to give you 5. Now, I want you to stop and think about that, and I want you to be very confident with an answer of those numbers don't exist. Okay, the only way I can multiply to 7 is a 1 and a 7. No matter who's negative and who's positive, there's no way I'm going to get a 5 out of that. Okay, so factoring doesn't work for this question. We need some other way to deal with this. And when we need another way, we turn to something called the quadratic formula. Okay, now here is the quadratic formula. Please don't get scared and write all this down thinking, oh my God, I have to memorize all this. No, you don't. This will always be given to you on a formula sheet. Okay, so don't stress about that. But here's what I was talking about. Remember I said we took some random quadratic. This is what I mean by a random quadratic. We have no numbers here, but we have A representing the coefficient in front of x squared, and we have B representing the coefficient in front of x, and then we have C representing the constant term. Okay, so if we have this set up that ax squared plus bx plus c equals 0, so just a gentle reminder at this point, you do have to have everything on one side and it has to equal 0, just like you would have with factoring. Okay, then what happens is my answers actually end up being this. Okay, you take your b value and you put the negative version of it in front, and then it's plus or minus the square root of b squared minus 4ac all over 2a. So again, that a, b, and c value are the numbers that are represented in the actual equation. Okay, so a is whatever coefficient is on x squared, b is whatever coefficient is on x, and c is your constant term. Okay, so our job today is just going to be practicing this and feeling comfortable using the formula. Okay, so just like with factoring, one side needs to equal 0. My big old head is going to be in the way there, so I'm going to just hide myself for a second while I put this other note up. Be super careful in how you write this stuff down. Okay, that is really important. For instance, where does your square root sign end? You need to make sure your square root sign goes all the way to the end of whatever that c value is. Okay, I often see kids, they only give me this part as the fraction. They don't put it all the way to the negative b. Your fraction has to go all the way over there. So little things like that cause communication errors, and they could end up giving you a completely different answer than what you were supposed to get. So just be really careful in how you're writing this stuff down. Okay. Okay, so let's try it. What we're going to do is we're going to go back to the last two examples, one that I could factor with and one that I couldn't factor with, and we're going to do them both with a quadratic formula just to see how the quadratic formula works. Okay, so that second last one that we did was x squared plus 8x plus 7 equals 0. I'm just going to hide myself for a quick sec so you can see the question. Okay, and what I want you to do is, first of all, always write the formula that you're going to use. Now, kids always whine at me about this. They're like, why do we have to keep writing the formula? The formula is given to you. It's a communication piece. By you writing this formula down in your work, you're saying, hey, reader, I'm going to use the quadratic formula. Okay, so write it down with the letters first, then figure out what all those letters mean. Okay, we know that in this equation, a is 1 because the coefficient on x squared is 1. B is 8 because the coefficient on x is 8. And c is 7 because the constant term is 7. So everywhere I see an A, I'm going to plug in 1. Everywhere where I see a B, I'm going to plug in 8. And everywhere where I see a C, I'm going to plug in 7. Okay, so the second line of my work is going to look like this. It's the exact same thing I just wrote, except I made all those substitutions. Okay, now the next step would be to take what's underneath the square root. I don't care that it's a square root right now. Don't put a square root in your calculator yet. I want what's underneath there to become one number underneath the square root. Okay, so in your calculator, you're going to grab your calculator, you're going to go 8 squared minus 4 times 1 times 7. Okay, and you're going to figure out what that number is. I believe it's 36. So now you're going to end up being negative 8 plus or minus the root of 36 all over 2. I also did the 2 times 1 at the same time. Okay. All right. This now splits into 2 different answers. But I want you to take note, hey, you know the root of 36. The root of 36 is 6. Okay. So what I end up having is negative 8 plus 6 all over 2. That's one answer. Well, negative 8 plus 6 is negative 2. Negative 2 divided by 2 is negative 1. Okay. Or I could have negative 8 minus 6 all over 2. That's where the two answers come from, is your plus and your minus, okay? So negative 8 minus 6 is negative 14, and negative 14 divided by 2 would be negative 7, okay? So take note, we got the same answers, the negative 1 and negative 7, we got the same answers factoring. This is just showing you how you would get it using the quadratic formula. All right, so let's try that second one that we couldn't factor with. Same sort of process though, okay? The very first thing I'm going to do is write the formula. Then I'm going to figure out, okay, what are my A, B, and C values? I know that my A value is 1, my B value is 5 this time, and my C value is negative 7, okay? So I plug all those in, and then I'm going to look at what's underneath the quadratic or the root here and get that as one number, okay? So 5 squared is 25. You can just do this right in your calculator, okay? But I'm looking at 25 plus 28 essentially, which gives me root 53. Again, on the bottom, 2 times 1 will give me 2. So x equals negative 5 plus or minus root 53 all over 2. Now I'm looking at that and I'm saying, hey, can I do anything else with that? Can I simplify root 53? Okay, little trip down memory lane back to 10C. Is there a perfect square factor of 53 that I could maybe break 53 down and then take that square root? No, there's not for this one. So this actually is my answer. Now, you don't have to split it into 2 when it's written like this. It's perfectly acceptable to just leave it exactly like this. But what I want you to understand is what that means. There are 2 different answers there. One is negative 5 plus root 53 all over 2. That's one of my answers. The other one is negative 5 minus root 53 all over 2. That would be my other answer. Okay? All right, awesome. Let's try this one. Again, we're going to do the same thing over and over and over again. Okay, we're going to start by writing the formula that we're using, which is the quadratic formula. Okay, and again, that's always going to be given to you. You don't have to memorize that. Let's take stock of what I have. A is 2, B is negative 2, and C is negative 1. I'm just going to hide myself so you can see that, just in case my big old head is covering it. Okay, now, this one's a little different because B is negative. So just 2 things you need to be careful of. If this says negative B, and I'm putting in negative 2 for B, that's going to turn to be positive because it's going to be negative, negative. Okay. The other thing you got to watch is on the B squared, make sure that you put the negative 2 in a set of brackets. Otherwise, the 2 or the square won't apply. This, oh, sorry, that's not what I wanted to say. Let me just take that off. This and this means something very different in your calculator, okay? This is going to give you an answer of negative 4, while this gives you an answer of positive 4. This is the one you want because the negative is part of the number that's being squared, okay? So when you write negatives in there, just make sure you're writing the negative 2 in a set of brackets, and make sure you think about that as you input it into your calculator, okay? So this is what we'd be looking at. Now, again, I'm going to get what's underneath the square root as one number, which is going to be 4 plus 8. I believe that number will be 12. So I end up with 2 plus or minus root 12 over 4. Where did the 4 come from? It was the 2 times 2 here. Okay. All right. Now I got to think to myself, okay, can I simplify the root 12? And this time I can, right? Root 12 is the same as saying root 4 times root 3. Okay, and then I know root 4 is a perfect square, so I can change that to 2 root 3. Okay, so I'm going to do that in my simplification process. So now I've got 2 plus or minus 2 root 3 all over 4. Now, one more step on this guy, I can see that all of these are divisible by 2. So it's just like I can reduce the fraction that I see. Okay, so I'm going to change that to x equals 1 plus or minus 1 root 3 all over 2. Now, I don't actually need the 1 there. Okay, I did it just so that you could see what I was doing, but you can just call that root 3. Okay, awesome. So that's the quadratic formula. Okay, all you got to do with this is practice writing the formula down, making sure you're plugging the right numbers into the right places, and then making sure you're calculating it proper after that. Okay, so that's the mission that you guys now have. I've posted the homework for you here if you are my kid in school. Make sure you're doing lots of practice. Make sure you're asking me lots of questions. You guys got this, okay? I'll see you in the next video where we're going to actually wrap up this unit and talk a little bit about applications of quadratic equations, okay? Until then, keep doing lots of math and keep asking questions. Take care, guys.